Hi everyone, I'm going to give my demo on arithmetic progression, which is shortly called as AP. Before we are going to discuss about the topic, I'm just going to give you some of the examples that we are going to observe in our day-to-day life. The first example I'm going to take is the number system. So you all know we are going to take the example of natural number system or whole number system or even integers. So in what way we are going to write? We are going to start with 1, 2, 3, 4 and so on. When a third grader is going to give you the answer, what is the next number after 4? Then he is going to give you the answer as 5 without knowing what a progression is. Okay. Whole numbers are going to start from 0, 1, 2, 3, 4, 5, 6. If you ask them, what is the next number of 6? 7. Like that, you are going to take integers as an example. You take the example of a natural number, whole number or even integer. You are going to find a definite pattern when the numbers are going to be moved forward. When you are going to move from left to right or right to left, you are going to observe a definite pattern. You are not going to get 10 here. You are going to get 6 only. Okay, we'll take example from physics. Uniform acceleration is a general term that we are going to use on class 11th. That is uniform acceleration. So what is acceleration? Change in the velocity over the time is what we call as acceleration. If you take uniform acceleration as an example, the body is here at position A, B, C, D, E, F. Okay, these are some of the positions of the bodies. From A to B, the body's velocity is 5. From B to C, it's 10. C to D, it's 15, 20, 25. Every time, the time taken is 1 second. Now, can we say the body is moving in uniform acceleration? Yes, because it is maintaining equal velocities in equal time intervals. Okay, now observe what is the difference between 5 and 10? Increased by 5, increased by 5, increased by 5 and increased by 5. Such an acceleration is what we called as uniform acceleration. Here also you can observe a definite pattern. Every time 5 is added. Okay, we'll take an example. My father has given me 100 rupees pocket money. And he told me that whoever the person you are going to see, you have to give them 10 rupees. Okay, now I have 100 rupees initially with me. Now the first person, I came to a first person, then I have given 10 rupees, then I have 90 rupees with me. Second person, third person, fourth person, like that I am going to give the money. Then you are going to observe this pattern and this pattern. Here 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. Every time we are going to add a fixed number. Here the prominence is for the fixed number that we are going to add. Okay. 100 minus 10, minus 10, minus 10 and minus 10. Here we are going to subtract by a fixed number that we are going to observe. Every time I am subtracting 10. That is the fixed number here. Okay, we'll take example of taxi fares that we are going to see. Okay, let us take any company as an example. 50 rupees is considered as the fixed amount. And then you are going to find charge per kilometer. Let us take the charge per kilometer is 15 rupees. For the first kilometer, when you are going to get into the taxi, you have to pay 50 and then 65 and then 80 and then 95 and so on. Per every kilometer, the charge is going to change like this. Every time the 15 rupees is going to be added. So from this example as well as all the examples that we are going to understand, one thing is clear, that is, if you know the first term, let us take 100, and if you know what number is to be added or subtracted, either added or subtracted, let us take the fixed number is 20 to be added. Then what is the next term? 120, the next term 140, the next term 160, like this. Let us take the fixed number is minus 20, then 100, then 80, 60, 40 and so on. So here we are going to move forward by adding a fixed number or by subtracting a fixed number. then such a series is what we called as arithmetic progression. So what is arithmetic progression? The progression which is forwarded by either adding or subtracting by a fixed number. That fixed number is what we called as common difference, denoted by the symbol D. So this is going to play a very important role in arithmetic progression. So if you know the first term, that means I am going to start with 1500 and the fixed number is plus 100. Then what is the next term? What is the next term? And then we can easily understand it can be 1600, 1700, like that it is going to be go on. Then whenever you have to check whether the progression is in arithmetic progression or not, you have to check for the common difference. That common difference should be a constant. For example, okay, we'll move on. I'm going to take an example and we are going to check whether the progression is arithmetic progression or not. Take example of 10, 12, 13, 15, 17, 19 and so on. Now observe carefully. Here the difference is I have added plus 2. Here I have added plus 1. Then immediately this is not considered as an arithmetic progression because the number is not fixed. Even though everywhere the number is plus 2. But even one time it is failed to maintain the common difference. Then we can't call it as arithmetic progression. Okay. Now tell me, in arithmetic progression, we are going to take the first term as A. So A is our first term. A. Then what is the next number? I told you the common difference is to be added. Let us take it as D. What is the next term? I have to add the common difference again. I have to add the common difference again and so on. Now the first term is A. The second term is A plus, can I say 1D? Okay, 1 into D. Here it is A plus 2D. Here it is A plus 3D and so on. Observe carefully. This is my term 1, this is my term 2, this is my term 3 and this is my term 4. Now, for the first term it is A, the second term is A plus 1D. Observe these two. 1 less than 2 is 1. The third term is A plus 2D and the fourth term is A plus 3D. Now, can you please tell me what is my 100th term? A plus 100 minus 1, that is 99D. Then what is my nth term? Nth term, it may be any number. Nth term is A plus, if it is 100, I have written 99. If it is 4, I have written 3. Then obviously I have to written n minus 1 times D. So this is how I am going to say about the nth term of NAP, which is denoted by Tn or sometimes An, or even we can denote it by L, last term. So last term of the arithmetic progression are nth term of the arithmetic progression are nth term again of the arithmetic progression is A plus n minus 1 times D. This is how we are going to write the general term or common term of an arithmetic progression. Here you have to understand about A, D and N. What type of numbers they should be. Okay, very important. A may be any number, that means A can be a real number. D may be any number, that means D can be a real number. But you have to understand about N here. N cannot be a real number. N is only a positive integer. Because you can say 10th term, you can say 15th term, you can't say root 2 term, or you can't say 10 and half term. Okay, so the N always should be a natural number, or you can say positive integer. See, observe some of the patterns of arithmetic progression, how the height of the step is going to be maintained, how the glasses are going to be arranged in this pattern. For fun, you are going to observe this. If this pattern is not going to be maintained, the glasses are going to fall down. So here, this is what we called about arithmetic progression. And now, if you want to know about common difference, simple thing is, if you want to know common difference, what you have to do? A2 minus A1 is the formula to find the common difference. Second term minus first term, or we can say the difference between any two successive terms of an arithmetic progression. Okay, A2 minus A1, or you can say A3 minus A2, or you can say an minus 1 is the formula to find the common difference of a arithmetic progression. So now we have seen two important formulas here. One is an of an arithmetic progression is a plus n minus 1 times b. This is also a formula for the last term of the arithmetic progression. And the formula for the d is, we can say an minus 1 is the formula to find the common difference. And to check whether the progression is AP or not, if three terms has been given to you, you have been asked to check whether it is arithmetic progression or not. Just go for it. A3 minus A2 should be equal to A2 minus A1. If it is, then it is considered as an arithmetic progression. Okay. Now we are going to see an example. If there are n arithmetic means between A and B, then find the common difference D. Okay. So what is the question? There are n arithmetic means between A and B. That means there are n terms are there between A and B. Then we have to find out D. Okay, let's write. First term is A and it is obvious that the last term is B. And I don't know, these are arithmetic means are there, some AM1, AM2, AM3, like that up to AMN. There are n arithmetic means are there. Now could you please tell me how many terms are there in this progression? These are already n arithmetic means are there. First term is A and the last term is B. That means total number of terms is equal to n plus 2. Is it clear? Total number of terms are n plus 2. N are these. Two terms are here. First one is A and the last one is B. That's why the total number of terms is equal to A plus n plus 2. Now, what is our formula to find an or even L? What is the answer for us? A plus n minus 1 times D and the last term is B. First term is A. Now, A is A. Total number of terms are n plus 2. That's why I have written n plus 2 here, and here it is minus 1 times D is equal to B. The transposition of plus A is minus A. That's why we are going to write it as n plus 2 minus 1 is plus 1 times D is equal to B. The transposition of plus A is minus A. That's why we are going to write it as D is equal to B minus A over n plus 1 is the formula to find n arithmetic means are there in between A and B. Then the common difference formula is D equals to B minus A over n plus 1 is the formula. Now we are going to see another important aspect of arithmetic progression, that is sum to n terms of an arithmetic progression. What is sum to n terms? Sum to n terms of an arithmetic progression. For example, you are going to have 1 plus 3 plus 5 plus 7 and so on. Okay, let us take this as an example. Now, are they in AP or not? Shall we check? See here, plus 2 and plus 2, it is obvious that is AP. See, we are going to visualize it. Okay, we'll take 1 dot, 3 dots, 1, 2, 3, 4, 5 dots, 1, 2, 3, 4, 5, 6, 7 dots. Okay, I just visualized them in numbers into dots. Okay, and this is our AP. Okay, this is my AP. Okay, I'm going to write the AP again, but in a reverse manner. See, in what way I'm going to write? 1, 2, 3, 4, 5, 6, 7 dots. 1, 2, 3, 4, 5 dots. 1, 2, 3 dots and 1 dot. Now, I'm going to join them together. I'm going to add them. This AP and this AP are going to be joined. Then, can I make them right here? See, this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here 5 are there. 1, 2, 3, 4, 5. Here 3 are there. We can write it as 1, 2, 3. Here 1 is there. I can write it as 1, 2, 3, 4, 5, 6, 7, 8. See? Now you are going to observe a rectangle has been formed and it is easy to calculate them. See what way I am going to calculate. Can you guess in what way we are going to calculate now? See, 1, 2, 3, 4 terms are there. See, I am going to write 4 times. What is the first term? First term is 1 plus. What is the last term? Last term is 7. But this is the sum of 2 APs. Am I right or not? This is the sum of 2 APs. But I am just going for 1 AP. That's why AP is going to become 4 into 1 plus 7 over this into 2. Transposition is by 2. Then what is our answer? 4 times 8 by 2. By cancelling it, you are going to get 16. Add them. 1 plus 3 is 4 plus 9. 5 is 9. This is 16. By this, we can clearly understand a formula for sum of arithmetic progression. What is that? See. How many terms are there? How many terms are there? How many terms are there? N terms are there. What is my first term? First term is A. What is my last term? Last term is L. And what I have done? By 2, because I have added twice. That's why I am dividing twice by twice 2. Now this is the formula for the sum of arithmetic progression. What is that? Sn equals to n by 2 times A plus L. Okay, if you don't know the last term, then what we have to do? See, then Sn equals to n by 2 times A plus, last term formula is the nth term formula, A plus n minus 1 times B. So Sn equals to n by 2 times A plus A is 2A plus n minus 1 times B. This is how we are going to find the sum to n terms of an arithmetic progression. Do you know this formula has been given by Arithmetic? Okay, we are going to think that this was given by Gauss, but it was actually given by Arithmetic. So what is the formula to find sum of n natural numbers as actually given by him? That is denoted by sigma n equals to n times n plus 1 by 2. But this is applied for the sum of natural numbers. This is sum of any arithmetic progression n by 2 times 2a plus n minus 1 times b. Can be applied. If you know the last term, you can use this formula Sn equals to n by 2 times A plus L. These are the important formulas we have. Now, we are going to go through an important example that I am going to give. I will write the question first. Let me pause the video.